In today's video, we'll be getting additional practice with using side angle side in order to prove triangles are congruent. So in the first couple examples we're going to look at, we're given a diagram and some partially given information. And we need to determine what other statements we would need to be given in order to use side angle side. So in the first one, notice we're given that AB and DC are congruent to each other. So the first step is I'm going to label this in my picture by using the same number of dashes. If we're trying to use side angle side to prove these two triangles are congruent, this pair of congruent sides is 1S toward SAS. Now we're trying to determine what other pieces of information would need to be given to us. So in order to come up with the minimum number of statements necessary, I'm going to look at my diagram next. And hopefully you'll notice that these two triangles overlap, sharing segment BC. And this would be by the reflexive property. So this would be a second pair of sides toward SAS, meaning we really only need to be given one pair of congruent angles in order to use side angle side. But the pair of angles we need to be given are congruent is important. Looking at our diagram, if we want to show that triangle ABC is congruent to triangle DCB, and we're given that AB and DC are congruent and BC is congruent to itself by the reflexive property, then the angle we need to be given information about is the one between the two pairs of sides that are given to be congruent. So that would be angle ABC in this yellow triangle, and it would be angle DCB in the second triangle. That would be what we call the included pair of angles. And then we'd be able to use side angle side. Now sometimes the given information won't simply give us that we have congruent angles, but they'll give us other information that we really need to know the meaning of the vocabulary in order to break down. What I mean by this is instead of telling us these angles are congruent directly, what they could have given us in the problem is that we had perpendicular lines. If AB is perpendicular to BC and DC is also perpendicular to BC, then we would end up being able to say the angles are congruent too, but it would just take a couple extra steps. If these lines are perpendicular, then that would mean angle ABC and angle DCB are right angles. And based on what we've talked about earlier in the year, if I know I have right angles at angle B and C, then they have to be congruent since all right angles are congruent. Let's take a look at another example. In number 2, they're giving us that segment AB and segment RS are congruent. Again, this is a pair of sides right away in the two triangles we're asked to prove are congruent. The second piece of given information is telling us that those same line segments are parallel. Anytime we're given parallel lines in proofs, we want to think back to the angle relationships we talked about earlier in the year. So you want to be on the lookout for alternate interior angles, corresponding angles, and you really want to focus in on an angle relationship for angles that are parts of the triangles you want to show are congruent. So if you notice here, we're given a transversal to these parallel lines. This angle, ABC, and this angle, RST, happen to be angles in the two triangles we're trying to show are congruent and corresponding angles. So we wouldn't be given that these angles are congruent as a separate given piece of information. We say that this is true since the lines are parallel. And that would count as a first pair of angles. So now we would have an S and an A towards side angle side. That would mean we would need one additional pair of sides to be congruent in the two triangles. Now, if you look at the triangle highlighted in yellow, the order of the sides and the angles we're given are important. AB is one side, angle ABC is an angle. We would need to be given the other side, CB, is congruent to its corresponding side, TS, in the second triangle. Only then would we have enough information to use side angle side. On the next page, we're going to take a look at some formal proofs. First, there's one additional theorem we need to talk about that's going to show up hundreds of times in the next couple units. Corresponding parts of congruent triangles are congruent. Now, since this is a rather long reason to write out, I am going to allow you to use the abbreviation CPCTC as long as you remember what the abbreviation stands for. So what this theorem says is if we're given two triangles are congruent, let's call them triangles ABC and triangle DEF. Now, we could be given these triangles are congruent, or maybe we have just proved those triangles are congruent using a theorem like side angle side. Well, if we know the triangles are congruent, then there must exist a sequence of rigid motions that would map one onto the other. Now, with rigid motions, we know distance and angle measure are preserved. So that really means each pair of corresponding angles would have to be congruent. So A would be congruent to D, B would be congruent to angle E, and angle C would be congruent to angle F. But also distance is preserved, meaning each pair of congruent sides would be, corresponding sides, would be congruent as well. That means side AC would be congruent to side DF, side BC would be congruent to side EF, and side AB would be congruent to side DE. So together, the three pairs of corresponding angles and the three pairs of corresponding sides would all be congruent. And those together are what we call the corresponding parts. Now, this is a really important theorem because in a lot of proofs, we're not asked to just prove that triangles are congruent, but instead we're asked to prove a pair of sides or a pair of angles in the two triangles are congruent. So this theorem allows us to first prove the triangles are congruent by using side angle side, and then say that the corresponding angles or sides are congruent as a result. Let's take a look at an example. This will be our first formal proof that we complete entirely. For any proof, we always start off by creating a two-column T-chart. On the left column, we're going to fill in statements up on the top, and on the right column, reasons. Now, the statement side is each side is going to be numbered, and the statement side is going to include a bunch of facts that we know to be true, starting with what we're told in the problem that is true. Ultimately, we're going to try to reach this statement we're asked to prove. On the right side, we're going to be using definitions and theorems we've talked about this year to support why our statements are true. So let's go ahead and get started. In this particular proof, notice we're asked to show that segment EC and segment FB are congruent to each other. A great strategy to start off with is to work backwards and come up with a plan of attack. So if we're trying to show these two segments in red are congruent to each other, our goal first would be to prove that the triangles that those are corresponding sides in are congruent first. In this case, EC is a side of triangle EAC, and FB is a side of triangle FDB. So if we can show these two triangles are congruent, then all their corresponding parts would have to be congruent. And EC and FB is a pair of corresponding sides. So now I have a goal to show that these two overlapping triangles are congruent to each other. So now we'll go ahead and start with our given information and see if we can get to this point. So we'll go ahead and list out our given information and label it in the diagram. So the reason we use for the given information is simply given. It was given to us to be true in the problem. Now, I always like to start with the given information that tells us that segments are congruent and angles are congruent, because there's really no symbols or vocabulary terms that we need to break down. So here they tell us AC is congruent to DB, and I'm going to mark that in my diagram. When the segments overlap, I tend to use these brackets because putting dashes makes it difficult to see which sides we're actually talking about. When I use these curly braces, notice that those segments labeled in blue are a pair of sides in the triangles we're trying to show are congruent. So that's one S towards side angle side. And I like to keep track to the left of my statements column of that information we know. The other piece of information regarding congruent segments is that AE is congruent to DF. I'm going to mark it in my diagram, and again, that's a pair of sides in the two triangles we're trying to show are congruent. So I already have two S's towards side angle side. The remaining pieces of given information we're going to need to do a little more work with. And that's because we're not told that segments or angles are congruent, but we're given this symbol which means perpendicular lines. So if EA is perpendicular to AD, we need to know what perpendicular lines mean or what they do. From earlier in the year, we talked about the fact that perpendicular lines intersect, forming right angles. So I can label in my picture that angle A is a right angle, and if FD and AD are perpendicular, angle D is a right angle. Now, anything we label in the picture, we want to make sure we write out in our proofs, because the proof, the statements and reasons, is what I actually grade. So on the statement side, angle A and D are right angles, and the reason is the definition of perpendicular lines. Perpendicular lines intersect, forming right angles. Now, I don't quite have side angle side yet because I still haven't written that any angles are congruent. But if angle A and D are both right angles, we can say they're congruent because all right angles are congruent, because they all measure 90 degrees. Now, the order we list out the statements in our proof doesn't have to be in the order of SAS. What's important is when you look at your diagram that we have two pairs of congruent corresponding sides, and the included pair of angles are congruent. So based on our diagram, we can say that the triangles are congruent by side angle side. That's triangle EAC and triangle FDB. Now, when we write side angle side in our proof, I'm going to have you write SAS is congruent to SAS. And that simply means the two sides of one triangle and their included angle are congruent to the corresponding two sides of the second triangle and their included angle. Now, we have to be really careful with this statement where we write that the two triangles are congruent, because we need to make sure the order of this second triangle matches up the corresponding angles to the first triangle. Here's what I mean by this. If we look at our picture, notice how I named the first triangle in the order EAC. So when I list out the second triangle, I need to make sure that the first letter is the angle that corresponds to angle E. There's a couple ways to do this. If you look at the picture, notice how angle E is an angle with no markings. Angle F also has no markings in the second triangle. Some students prefer to think of transformations or rigid motions. You can imagine that this triangle was reflected to give us FDB. So E would map onto F. Looking at the next letter, I used angle A in triangle EAC. That's the angle that's the right angle. So in my second triangle, I needed to make sure I used the letter D next, since that was the right angle in the second triangle. And then I used the remaining angles last. So it doesn't matter which order you list out the first triangle and how you name it, but you do need to make sure the order of the second triangle matches based on corresponding sides and angles. Now, once we've proven the triangles are congruent, then we're able to say exactly what we wanted, that EC is congruent to FB. And that's because if the triangles are congruent, all of their corresponding parts must be congruent as well. So corresponding parts of congruent triangles are congruent, or the abbreviation CPCTC. Let's go ahead and try one more. In the next example we'll look at, we're asked to prove that M is the midpoint of LJ. Again, I'll use the strategy of working backwards to try to identify a pair of triangles that we'll want to show are congruent. In order for M to be the midpoint of LJ, that means that M has to divide LJ into two congruent segments. So if I can show that LM and JM are congruent to each other, then that would mean M would have to be a midpoint of that segment. Now luckily in this example, LM and JM are corresponding sides in these two triangles, the one in yellow and the one in pink. So if I can first prove that triangle LMK is congruent to triangle JMK, then I think we'll be able to prove the segments are congruent by CPCTC. So now that we've come up with a plan of attack, let's go ahead and write out our statements and reasons, starting with our given. We'll go ahead and draw in our T-chart. And I'll start with the given information. KM bisects angle LKJ, and so LK and JK are congruent, both given. Now, as I mentioned earlier, I always like to start with the given information. That's the most straightforward. So anytime they give us congruent segments or angles, I'll start by labeling those in my picture. In this case, LK and JK happen to be a pair of sides in the two triangles we're trying to show are congruent. So I'll write a little S out in front of that statement. And I'm actually going to write it right out in front of the given, since that's where they told us the sides were congruent. That's already one S toward SAS. Next, we'll look at the other piece of given information. In our diagram, if KM bisects angle LKJ, that means it's an angle bisector, which divides this angle into two congruent angles. So angle LKM must be congruent to angle JKM. That's because an angle bisector divides an angle into two congruent angles. This is a pair of angles in the two triangles we're looking to prove are congruent. Now that we're out of given information, we need to turn our attention to the diagram and see if there's any angles or sides we can say are congruent just by looking at the picture. Now, we have to be careful not to assume anything that's not given to us. We can't say that the lines are perpendicular. We can't say that angles are congruent unless they happen to be vertical angles, or unless there's a shared side or angle where we can use the reflexive property. In this question, notice how the two triangles in yellow and pink share side KM. So I can use that as our last pair of sides needed, since we have the reflexive property. So I'll list that KM is congruent to itself by the reflexive property. This is the last pair of sides we'll need in order to use side angle side. Notice how in the diagram we have two pairs of congruent sides, and the pair of angles included between those sides are congruent too. Now, since we worked backwards in the beginning, the rest of the proof nicely falls in line. In step 4, we know triangle LMK is congruent to triangle JMK by side angle side. Now I'm going to double check and make sure that the order matches up between the two triangles. So if the first triangle I named LMK, the next triangle I'd have to start with J, then M, and end with K, since that matches up the markings for congruent sides and angles. Then in step 5, if we know triangles are congruent, we know that each pair of their corresponding sides and each pair of their corresponding angles also have to be congruent. That's what we abbreviate with CPCTC. Corresponding parts of congruent triangles are congruent. And then once we know LM and JM are congruent, Notice how I'm marking that in with a separate number of dashes. Then we can finally say M must be the midpoint of LJ, just like we wanted to prove. The reason for that goes back to our first unit of the year. A midpoint divides a segment into two congruent segments. This is where we'll stop today. Tomorrow we'll get a lot more practice in class.